Hello everyone. So myself Shubham Banerjee. Today I am going to discuss about very important topic, that is your differentiability. So one question be there. So very important question, that is check differentiability at x equal to 0 for the function given fx equal to e to the power x minus 1 by x not equal to 0 and equal to 1, x equal to 0. So how you have to check your differentiability? Basic definition first you have to know, that is for differentiability you know that limit x tends to c fx minus f of c by x minus c exists. If you see that, so this limit is exists, that means function is differentiable. Fx is differentiable at x equal to c. This is the basic definition of differentiability. And what do you mean by this limit form? And now later on I will discuss, so what is the basic meaning this fx minus fc by x minus c. Actually this is your slope of a line, and this whole geometrical concept of differentiability, that is slope of tangent. So later on I will discuss the definition, regarding definition, all these things. Now you have to just remember that form, that when fx is differentiable at x equal to c, so we have to apply this limit form. Limit x tends to c fx minus fc by x minus t. If it exists, limit is exist, then you can say that function is differentiable at x equal to c. Now comes to your given function. Fx is given and we have to work on that particular point x equal to 0. So now look at this function is fx equal to e to the power x. Fx is equal to e to the power x minus 1 by x if x not equal to 0, and 1 if x equal to 0. Now look at this first condition. If x not equal to 0, then the function is like that. Okay, so what is the condition x not equal to 0? What do you mean by x not equal to 0? That suggests that if x is less than 0, or second condition is it is also possible x greater than 0. X not equal to 0 meaning that is x less than 0 or x greater than 0. As well as when x equal to 0, that time the value of the function is 1. So this is the basic form. Okay, so now comes to one diagram, very important diagram. So draw one number line. You can draw one number line and you have to check the point, check on your point x equal to 0. So you have put here on your number line x equal to 0 and look at this point. So first of all, this limit is exist, that means left hand derivative equal to right hand derivative. So what do you mean by left hand derivative? Left hand derivative is equal to limit x tends to c negative fx minus fc by x minus c, and right hand derivative means limit x tends to c plus fx minus fc by x minus c. If these two are equal, then you can say that limit is exist. Now first of all you have to check left hand derivative. That means we have to count from left side towards x equal to 0. So comes from left side towards 0, close to 0. So that portion, that is your left hand derivative. Now look at this, close to 0, you can take any point but not 0. You can't take x equal to 0. Close to 0 you can take, let us take like minus 0.1. Whatever point you can take, you can use, but close point you have to take. And obviously that point is less than 0. X equal to minus 0.1, that point is less than 0. So when x less than 0, that time the value of the function fx is equal to e to the power x minus 1 by x. Then right here. And now what comes from right hand side, close to 0, that is your right hand derivative. So when it comes from right side to x tends to x equal to 0, so that time you can take one close point from right side x equal to 0.1, like that. So obviously that point is greater than 0. if x greater than 0, that time the value of the function again same, e to the power x minus 1 by x. Okay, and particularly x equal to 0 point, that time the value of the function f of 0 is equal to 1. Okay, because already according to your function f of 0, when x equal to 0, function value of the function is 1. Now comes to your analytical definition, you have to check your left hand derivative. So left hand derivative is equal to limit x tends to, now we have to work on 0, so that's why 0 minus fx minus f of 0 by x minus 0. So this is the general definition, x tends to c. Now comes to a particular point, x equal to 0, that means c replaced by 0. So fx minus fc, so that's why f of 0, c replaced by 0 by x minus c means x minus 0. Now is equal to limit x tends to 0 negative. Now from comes to left hand side, that time the function value is e to the power x minus 1 by x, and f of 0 value is 1 divided by x. Okay, so now comes to limiting value. Okay, so you can take your LCM. So limit x tends to 0 negative e to the power x minus 1 minus x by x square, you can take LCM. Okay, so now if you put 0, so both sides is a 0 by 0 form. You can see e to the power 0 is 1, minus 1, that is 0, and you can put here x 0 and 0. So this is your 0 by 0 form. So that time you can apply your L'Hospital rule. Numerator derivative and denominator derivative. That is called your L'Hospital rule. So we can apply that rule also. Okay, so next thing we can solve, that is, so that is this left hand derivative is equal to limit x tends to 0 negative, that is e to the power, what is derivative of e to the power x, e to the power x, and constant derivative is 0 and x derivative is 1 divided by derivative of x square is 2x. Now we can see e to the power x minus 1 by 2x. If you put again x 0, so you can see the 0 by 0 form. Again 0 by 0 form means, that means you have to apply L'Hospital rule. So again the derivative, numerator derivative, e to the power x derivative, again e to the power x constant derivative 0 and 2x derivative 2. Now you can put x equal to 0, that means e to the power 0 by 2 is equal to 1 by 2. So that means limiting value is 1 by 2 from left hand side. Okay, so that is your left hand derivative is your 1 by 2. Now similarly you can check for right hand derivative. So for right hand derivative, limit x tends to 0 plus fx minus f0 by x minus 0. So same function you can use here. So that is e to the power x minus 1 by x minus 1, f of 0 value is 1 by x, same already I done here. So that value also again 1 by 2. So you can see that left hand derivative is equal to right hand derivative clearly. So that suggests that fx is differentiable at x equal to 0. So in that way you can solve this type of problem, and this problem is a very important for differentiability condition check. Okay, that is all students. Thank you. Take care. Bye bye.